So I'm so thankful that for your kind cooperation, all of you are keeping silent and listening so passionately. So here you can see another interesting topic or model you can see. By them they have already taken out the carom board here. So I am also very excited, and the topic is about laws of motion. So without wasting further time, I like them to carry out the topic, and with a slight introduction of yourself. Congratulations, all the best.
So, good morning to everyone. My name is Rohan Kaya. Today, I came over here with my team members to demonstrate our topic, laws of motion. So, first I would like to call Nia to explain the first law of motion.
So let's know about the first law of motion.
Very good boys, huh?
First law of motion is also known as law of inertia. So what is inertia? Inertia is the property of an object which resists any change. So it means that if the body is in rest, it tends to be in rest, and if the body is moving, it tends to keep moving. So let's see this by a practical example.
So now the body is in rest, and this is it. Now when I hit it,
Wow!
it goes out.
Yes.
Because this is a body in rest, so it tends to be in rest. So now it is in the same position as it was, and the other it went because it came into motion, sudden motion.
Now let's know about the second law of motion. So I would like to request Taya to tell us about the second law of motion.
Now I'm going to tell you about the second law of motion. It states that the rate of change of momentum of an object is directly proportional to the applied unbalanced force in the direction of force. Which means that acceleration depends upon two factors. First one is the net force applied on the object, and the second is the mass of the object. If the mass is more and the force is applied, then the acceleration will be less. So I want to show you with a practical. So as you see, this is a toy car, and when I push it from this point A to point B, it goes. But now when I apply more mass, it covers less distance after applying the same force. So it is because when the mass increases, even though you apply same force, but the acceleration decreases. So it was the second law of motion. Now I would like to call Joel to demonstrate the third law of motion.
Very good, very good.
This is the third law of motion, which is known as law of action reaction, which means every action has an equal and opposite reaction. Which means if you do action, it has an opposite, it is an equal reaction and which is opposite in direction. Assume this is a body A and this is body 2. When if you give a brief pressure to body A and it hits to body B, it reflects because body B also exerts the same pressure as which is applied by the same force which is applied by body A to body B, and it is opposite in the direction, but it is equal in the magnitude. Due to that, the coin reflects back. This is the third law of motion.
Finish? Okay, good. You need to polish your. Last question. Can you give some more principles where the third law of motion is being used in our day-to-day life? When you slide a person.
You get the damage in your hand also, and
the person who is getting missile in space, damage comes from both ways.
Any else?
Missile launch.
Missile launch, or you can say even you walk also. We are walking with the help of third law, right? Okay. What is momentum? What is momentum? Second law is all about momentum, right? Formula you are saying. Oh yeah, the product of mass and velocity. If I ask you the SI unit of momentum, what is the SI unit of? Because we already know that momentum is mass into velocity. Very easy question I am asked. You will do the formula. The mass unit is what? Kg. Velocity is meter per second. So if you combine it, it will be kg meter per second. Okay. Last question, as there are three members. What is inertia?
Inertia is the property of an object which resists any change.
Okay, very nice. Example, an example?
Example like we have given here, and many examples are there. When we keep some thing on the paper and pull papers easily, then
You can see the example in public bus also, right? Yeah, like a style in the bus. When the driver suddenly moves from the startup, the passenger tends to feel the excite. Why? Or when the driver suddenly apply brake also in the moving vehicles, they tends to move forward. Why? It is all about the inertia. All right, all the best. Very good. I feel so happy that you have participated in this program, in the presentation, and it will enhance your learning. How was the experience? To come here and explain the topic, how you feel? It was important. It was effective. In what sense? From better learning, for better learning. Understand? All right, all the best. Have a good day.